Hello, we're Group 1 and we had Engine 9. My name is Ben Jones. I modeled the crankshaft. We have David Gardner who modeled the piston. We have Monica Warren who modeled the camshaft, and James Kinnebrew who modeled our connecting rod. Alright, so starting with the crankshaft here. So starting on the gear side in particular, it's basically a combination of a bunch of different extruded cylinders. I won't go into the radiuses too much there. You can see the extruded cut I made on the end for it connecting to the other parts of the engine. Then here you can see the two extruded cuts I made on the top and the bottom to get some of that more features pulled out of it. Then we're going to move on our way to counterweights here, and you're going to make some show some of the geometry here. So basically this is an extruded circle that's a little offset, and then I cut off the edges of that, and then the straight down part, which is just a rectangle. Then we did the two circles here that connected to the other side of the crankshaft, and then I mirrored it about that second extruded circle. So going into some of the detailing of the counterweights here, I have a revolved a revolution of the top circle, as well as some extruded bosses to get the overall curvature. Then I had another extruded boss that also followed around the edge of that circle to get more of the curvature, and a fillet to make it all come together. Now here you can see that we actually have some draft angles that I had to format. So going about and doing that, first I had to make the bulging out of the inside part, and then I had to do a 1 degree cutout and a distance cutout on the inside and outside to get the bulging center of the different counterweights. Did the same for the other side, had a bit of a different dimensions on that, but the same process in general. The second counterweight also had some more detailing in terms of an extruded cut and an extruded boss on the top, right through the center on the left side. So I modeled both of those with a offset entities tool. And then I added some fillets to give it its overall structure. Moving on to the curvature of the other side of the crankshaft, we have here a extruded boss that I extruded up to surface around the cylinder there where it connects to the other side of the crankshaft to give it that rounded edge, as well as then I added some fillets and extruded bosses and a loft to connect it to make the rest of the curvature. Adding some more extruded bosses and the fillets, we get our final shape. And then we're moving on to the right side where the gear is not. Once again, a stack of extruded cylinders of different radii, pointing out two in particular here that had different draft angles. And then adding our cosmetic threading, an extruded cut on the top, and an extruded circular cut with a draft angle on the end will give us our final shape. And then we add the gear on the end, which was made with the gear toolbox add-in. Put it onto the right plane with the right distance offset, added the timing mark, which is just an extruded circle cut. And that gives us our final shape. And I'm going to move on to David, who's going to talk about the piston.
Alright, starting with the piston head, what I did is a revolved feature with all these different lengths in here. From there, I had to create a cutout from the right face of this piston head and mirror it across the plane that you see over here. From there, I had to place a lot of material back in to create the two faces you see here. And then from there, I had to draw this out on the face there and cut it through all to create the little cutout on the bottom of the piston head that you see. From there, I had to create the little half circles on the edge of the bottom of the piston head. I did that by creating a rectangle and then extruding cut the circle feature and then mirroring that across the entire piston head. From there, I had to create the pieces that are holding the pin in place, and I did that by just extruding that out, cutting off the little angle that it had on the top of the little half circle, and then extruding the place for the pin to go through and mirroring it across the piston. From there, I put the timing mark on, which I just did by making it rectangular and then cutting the half circle out on it. And then from there, I had to create a crescent shaped chamfer, and I did that by creating two circles and doing an angular cut on it. And from there, I went and put fillets in. I put 2 out on the outside, and there's 3 on the inside there. And from there, I had to create this little small circular cutout on the inside of both sides of the pin slot. And then from there, I went and put these cutouts on the face by cutting out the little triangles and doing a lofted cut for the bottom of the left and right most ones, and then just doing an oval cutout on the other ones. And then I modeled the pin, and that was just a one simple revolve cut and two chamfers. And then now we're going to move to Monica, who modeled the camshaft.
Okay, so for the camshaft, starting out, we just have an extruded circle on the front plane, and then a triangle was drawn on the right plane, and a revolved cut made the end there. From that, there are different size cylinders drawn on the face of each preceding cylinder until we get to this funky shape here at the rod. So each endpoint had a different spot that it landed on the face. So I measured each distance from the side and the top and gave it its endpoints and then their individual lengths to get this shape. And that's how it connects to each side, and the fillets were made around. Upon the face of that, we have the other cylinders that were drawn and extruded until we get to the gear. So the gear was a little bit different. You had to use a toolbox add-in where you set the diameter and the teeth, and then I inserted it and mated it to the face of this cylinder. On the other side of that, it was more circles extruded into cylinders with each of the diameters set, and then some of them were not completely aligned with the origins, so their distances were set from the offset of the origin, and I went back and put all the fillets in, and there is the camshaft. So next we have James talking about the connecting rod.
Okay, so with the connecting rod, I started out by creating this drawing you see here with the circles and the tangent arcs going into it, as well as lines and the other circle as well. And so I measured the angles at which these lines were going to, and distances and various things, and set all the reference geometry in order to get it to make the shape correctly. So the next thing I did was I had to create this inner cavity through the part, and as well as creating the raised sections on the small circle end of the part. Going forward, I added various little, I guess, extrusions throughout the part. One's this circular shape, another is the raised section through the hollow portion of it. It's not hollow, it's a indention through the part, and so those required various reference planes and extrusions from the part, as well as various other measurements. Going forward, I had to create more extrusions off the part, many of them requiring reference planes. Some were just cuts as far as the teeth, and making sure that matched up well with the small part. Then, of course, I extruded the hole and used the thread tool to properly thread that. And then I added fillets across it. And so moving on to the small part, we had a just basic arch, a basic half circle that was extruded up. I then cut an area around the middle of that, and then added in a triangle that swept across using a swept extrude. And then it was just a matter of extruding the various raised portions from that, as well as matching those teeth from the other part so that they would fit together correctly. And as you can see, this was just me adding this sort of defect-like indention as well as another indention, and then filleting the edges that needed to be filleted. And moving on to the prototype, which I will also be presenting, essentially what we did here is we wanted to reduce the weight of our design, and so obviously we wanted to remove the material to do so. And we decided that the best way to achieve this would be to create circles so that it would minimize the stress on the part. And the way it was distributed. And of course, we just did this by extruding holes in the thicker part of our part, holes gradually increasing in size as they went to the thicker part of the part. And that's our presentation.